Hello again, grade 8. You are going to complete the explanation of this chapter. So the inclined plane. An inclined plane is a simple machine with no moving parts. It is simply an even sloping surface that makes it easier for us to move objects to higher or lower surfaces than if we lifted the objects directly upwards. It is believed that ancient Egyptians used inclined planes to carry heavy stones to build the pyramids. So as you can see in the figure, this man is holding these stuff to the truck. It's easier for him to use this inclined plane than to hold them or lift them up. Inclined means a raised end or raised at one end. An inclined plane may be a constructed frame or just a piece of log leaning against a higher point. In the illustration, the man uses a piece of metal as a ramp to move the hand truck into the van. An inclined plane has a horizontal side A, the distance from the lower end of the slope to the base of the vertical. It also has a vertical side B from the base up to the top of the sloped surface. The sloped surface is where the man is pushing his hand truck. Now, this is the inclined plane and this is the object moving upward. So I have B and I have A. A is the vertical part and A is the horizontal part and B is the vertical part, and the inclined plane is the hypotenuse of this right triangle. Trade-off. There is a trade-off with this simple machine. If the slope is gentle, a person has to push or pull the object over a longer distance, but with very little effort. If the slope is steep, a person has to push or pull the object over a very short distance, but with more effort. So as you can see in the figure, I have two cases. The first one, I have a gentle slope. It means more distance but less force. In the second one, I have a steep slope, which means less distance but more force. Trade-off helps us to understand the mechanical advantage of inclined planes. For example, there is a greater mechanical advantage if the slope is gentle, because less force will be needed to move an object up or down the slope. Some good examples of inclined planes are accessibility ramps and roofs of houses. Now, the wedge. A wedge is simply a triangular tool, often made of metal, wood, stone, or plastic. It is thick on one end and tapers to a thin or sharp edge on the other end. As you can see, this figure is holds examples of many wedges. Technically, it is an inclined plane or two inclined planes put together to form a triangle that moves. A wedge may be attached to a handle to make it easier to use. Good examples of wedges are nails, knives, axes, and your teeth. Your teeth are considered wedges. So the wedge can be used in many ways: to cut, just like the knife, to split, just like the axe, to tighten and hold back, to hold together, to scrap. Wedges work by changing the direction and the force applied to it, and here is an illustration, the diagram of change in direction and the force. As you can see in the figure, I have a wedge, which is the axe, and I have an object, which is the wood. The force direction, it goes down, and then I have a change in direction in two different directions. The force applied to the thick end of the wedge overcomes the resistance of the wood. The force is directed downwards, but the wedge directs the force sideways as it drives into the wood. A wedge may be a single wedge or a double wedge. Each does a slightly different job. An axe is a double wedge and a chisel is a single wedge. The longer and thinner a wedge is, which means sharper, the more work it does with little effort. If the wedge is shorter and has a wider angle at the tip, one needs more force to do the work. So the mechanical advantage of a wedge is higher when the wedge is longer with a thinner tip. Wedges have been in use for millions of years. Earlier humans used wedges made of hard rocks and stones to hunt, cut, and trim trees and carve stones. The concept of wedges is also used in jets and modern cars. You will notice that jets, fast cars, speedboats, and trains have pointed noses. This helps them to cut through the air. This feature of pointed noses cutting through the air is known as aerodynamics. Now, the screw. A screw is simply an inclined plane around a cylinder. To describe this better, you can view it as a cylinder with a head at one end and a pointed tip like a nail at the other end. More importantly, it has ridges winding around it. The correct term for the ridges around the shaft or cylinder is the thread. So this is a screw. The distance between threads are the same for each screw but are different on other screws. The distance between the threads is called pitch. Screws are very useful for holding things together. They can pull or push an object together. They can be used to lift very heavy objects and tighten things together too. Nail and screw. These two are not the same. Unlike the nail, a screw has ridges around the shaft. It is harder to drive a screw into a piece of wood because the ridges on the screw create a lot of friction and resistance. To drive a screw into the wood, it has to turn in a circular motion by a screwdriver. Now, a bolt is a kind of screw but does not have a pointed tip. It is not drilled into place, but rather a hole is made for the bolt to go through. Then a nut is placed at the end of the screw, the bolts through. Bolts are very powerful in holding things together, as you can see in the figure. Now, drill bit. This is a type of screw that can make holes in wood, plastic, metal, and stones when attached to an electric drill. Like the regular drill, it is pointed at one end and it has threads too. The drill has deeper grooves that carry pieces of the wood from the hole to the surface as the drill bit turns. Now, examples of screws. Some good examples of screws are bolt screws, bottle tops, guitar tuners, light bulbs, faucet taps, and cork openers. Can you think of a screw device in your home? Of course, I believe all our homes are filled with examples of screws. Mechanical advantage. The mechanical advantage depends on the space between the threads and the length of the screw. The closer the threads are, the greater the mechanical advantage. It is easier to drive a screw into an object if the thread spacing is smaller. It takes less effort but more turns. If the space between the threads are wider, it is harder to drill a screw into an object. It takes more effort but fewer turns. The lever. A lever is simply a plank or ridged beam that is free to rotate on a pivot. It is perfect for lifting or moving heavy things. It is a very useful, simple machine, and you can find them everywhere. Good examples of levers include the seesaw, the crowbar, the fishing line, the oars, wheelbarrows, and the garden shovel. As you can see, this is a photo of a lever. Parts of a lever. Levers have 4 important parts: the bar or beam, the fulcrum, the pivot or the turning point, the effort or the force, and the load. The beam is simply a long plank. It may be wood, metal, or any durable material. The beam rests on a fulcrum, a point on the bar creating a pivot. When you push down one end of the lever, you apply a force, which is the input, to it. The lever pivots on the fulcrum and produces an output, which is lifting the load from the other side by exerting an output force on the load. A lever makes work easier by both increasing your input force and changing the direction of your input force. The three lever classes. The parts of the lever are not always the same in the same arrangement. The load, fulcrum, and effort may be at different places on the plank. So I have class 1 lever. In this class, the fulcrum is between the effort and the load. The mechanical advantage is more if the load is closer to the fulcrum. Example of class 1 lever includes seesaw, boat oars, and crowbar. This is class 1 lever in the figure. Now, class 2 lever. This is the figure of class 2 lever. In this class, the load is between the effort and the fulcrum. The mechanical advantage is more if the load is closer to the fulcrum. Examples of class 2 levers include wheelbarrows. Class 3 lever. In this class, the effort is between the load and the fulcrum. The mechanical advantage is more if the effort is closer to the load. An example of class 3 lever is a garden shovel, as you can see in the figure. The wheel and the axle. The simple machine involves two circular objects, a larger disc and a smaller cylinder, both joined at the center. The larger disc is called the wheel and the smaller cylindrical object or rod is referred to as the axle. Sometimes there may be two wheels attached to both ends of the axle. A wheel alone or an axle alone is not a simple machine. They need to be joined to be called a simple machine. Now, if you look closely at how a wheel and axle work, you will notice that it is a kind of class 1 lever. Here, an action on the axle, turning the axle, will cause an output at the other end, which is the wheel will turn too. The fulcrum is where the axle meets the wheel. The wheel and axle work in two basic ways. Let us take a screwdriver for instance. If you apply a force to the wheel, which is the handle, the wheel spins and multiplies the effort to make the output force of the axle, the shaft, greater. A simple doorknob is another great example of the wheel and axle. The locking mechanism of the doorknob is inside of the door and can only be controlled by the knob. Since it will be difficult turning the axle to open the door, you can turn the wheel instead, and that does the job for us. Now, let us consider a windmill. If you apply a force to the axle, it will multiply the force to the wheel, the blades, and result in a greater distance covered. It is because the wheel is larger than the axle and covers more area. A ceiling fan works in a similar way. As the axle turns, it powers the larger wheel, the fan blades, to cause the desired output. So the wheel and axle are perfect for turning turbines and fans. They are also used in automobiles. For example, when you turn the steering wheel of a car, your effort is multiplied by the axle and results in more turns of the car wheels. Gears. A gear is simply a special wheel with teeth called threads on the outside. Now, the pulley. Have you seen your school flag being raised before? Some schools do that, like every Monday morning. This is possible with a simple pulley. When you pull down on the rope, the pulley turns and the flag goes up. Pulleys change the direction of the force. A pulley is simply a wheel with a groove in it and a rope in the groove. It is also called a drum or a sheave. The groove is important because it helps to keep the rope in place. It is used to lift up or lower heavy objects. With a pulley, an object to be lifted can be tied to one end of the rope, and a force is applied to the other end by pulling the rope downwards. The downward force turns the wheel with the rope and pulls the load upwards to the other end. Now, types of pulleys. There are 3 types of pulleys. Each pulley system depends on how the wheel and rope are put together. I have the fixed pulley. This is the simplest form of pulleys. Simple pulleys have their axle fixed in place and cannot be moved. The rope moved in the groove of the pulley, but the wheel is fixed to one spot. So the wheel on your school flagpole is a good example. The movable pulley. In a movable pulley, check the photo. The load is attached to the pulley and both of them can move from place to place. In this type, one end of the rope is attached to a fixed point that does not move. With a movable pulley, you need less effort to lift a load. Can you tell how the movable pulley is similar to the Class 2 lever? Both of them have the load between the effort and the fulcrum. So this is the similarities between the movable pulley and the Class 2 lever. Compound pulley. This is called a compound pulley. It is a combination of pulleys designed to make the effort less than half of the weight of the load. This kind is very common at construction sites where cranes lift very heavy steel and concrete objects. One good example of a compound pulley is a block and a tack.